Okay, so today's lesson is on surface area of cones and spheres. So we already know one of our formulas. The formula for the surface area of a sphere we have looked at before. We'll write it down again now. So the surface area for a sphere is equal to 4 pi r squared. So let's get that down first of all. We have already looked at that. So then let's have a go at some of these questions then. So here's our first one. This one's quite easy. It says, sphere has a diameter of 30 centimeters. Determine the surface area of the sphere. Give your answer correct to one decimal place. So same as always, I'm going to write down what my radius is and what my diameter is. So in this case, it tells me the diameter is equal to 30 centimeters. Just before, if you're drawing this at home, best way to draw is draw a circle like that. And then you can just draw a little like oval in the middle there. It's the best way to draw these. So the diameter of this one is 30 centimeters, which means that my radius is equal to 15 centimeters. And then if I'm trying to find my surface area, I'm literally just subbing it into this formula here. So my surface area is equal to 4 pi times by r, which is 15 squared. Oops. So let's type it into my calculator. 4 shift pi times by 15 close bracket squared is equal to, in terms of pi, it's 900 pi centimeters squared. But they're asking it to, what are they asking it to? One decimal place. So let's change it S to D to one decimal place. That's going to be 2,827.4 centimeters squared. Nice and easy. Brilliant. So, have a little go at that one on the right-hand side. Have a little go at the one on the right-hand side. So some of you are getting that already. Super. So let's just have a quick go at this one then. So we know that my diameter is equal to 38 centimeters. My radius is going to be half of that, which is going to be equal to 38 divided by 2. 38 divided by 2, which is 19. Just checking. So I'm going to sub that in. Surface area is equal to 4 pi r squared, which is equal to 4 pi times by 19 squared. So let's do that on the calculator. So it's going to be 4 shift pi times by 19 all squared is equal to 4536.5 centimeters squared. Brilliant. Super. Get out of here. So, next one. Where is that not? So, next one, we're going to have a look at this one now. Now, this is new, okay? Now, the thing that we need, first of all, before we do anything, there's a new formula which we need to think about. Okay, you can even see it on here, actually. So, if I draw a cone like so, to remember to draw a cone, draw an oval at the bottom, pick a point at the top, and then connect these two up. Now, we usually say that we ignore the slanted lines to find the volume and things like this, but in this one here, we actually use this value here, which is called L, which is the slanted line on that cone, and we also need to know the radius here. So the curved surface area of a cone, so this is only the top part, okay? Now this is really important. So the curved the curved surface area of a cone is equal to pi r L. Pi r L. Now this here is only that top curved part round there. So it's only this part here, not the bottom. So it's only this part here. So let's just write that. Only the curved top part. Okay, it's only the curved top part there, not the bottom. I'm going to even say not the bottom circle there. Okay, so it's only the curved top part, not this bottom here. And just in case you needed to know the bottom, we know what the formula for the area of a circle is. That is equal to pi r squared. So we'll talk about this in a second. Get both of those down. Okay, and then let's have a go at this one here. This one here is example 2. Give you a second to get that down. So this one here says determine the surface area of the cone and give your answer to one decimal place. Now there's two things we need to work here. We need to work out that curved top part, which we know is using the formula pi r L. But we also need the circle on the bottom. So we'll do the curve. In fact, before anything, we'll write down what the radius and the diameter are. So the radius in this one is 15 centimeters. The diameter is equal to 30 centimeters. So the curved part is equal to pi r L. Now L is this, remember, L is the part which is that length, the diagonal length there. So this is equal to pi r L. So this is equal to pi times by my radius is 15 times by this length here, which is 33. Let's just work that out. So shift pi times by 15 times by 33 is, I'll do it in terms of pi for now, is equal to 495 pi centimeters squared because it's area. Okay? So that's the curved part, but we also need the circle on the bottom, which we know is equal to pi r squared. We know that. So this is equal to pi times by my radius, which is 15 squared, which is equal to, let's work that out, shift pi times by 15 all squared, which is equal to 225 pi. Now, to work out the total surface area, we need to add the curved part from the top, and we need to add the circle on the bottom. So it's that curved part around the side here, and the circle on the bottom. So this is going to be equal to 495 pi plus 225 pi. So plus 495 shift pi, which gives us a total of 720 pi for this one, centimetres squared, but we know that they want it to one decimal place. So change your S to D, and that answer there is going to be 2,261.9 centimetres squared. Brilliant. Super. So have a little go at that one on the the right hand side now. Have a little go. Oh, I'll just make sure you've got that there. Let's just get rid of that then. So have a little go at that one on the right hand side. Give you a few seconds to have a go at that. Brilliant. So some of you have already got that. Brilliant. Brilliant, brilliant. So let's have a go at both of these then. So the curved is equal to pi RL. Diameter is 20, which means that my radius is equal to 10. So this is equal to pi times by 10 times by 27, which is going to be equal to 270 pi centimetres squared. My curved surface area, or the circle at the bottom, sorry, is equal to pi r squared, which is equal to pi times by 10 squared, which is equal to 100 pi centimetres squared on the bottom. We add those together. 100 pi plus 270 pi is equal to 370 pi centimetres squared. We need that as a to one decimal place, which is 1,162.4 centimetres squared. Brilliant. Super. Just give you a second to get that down. Okay, so let's move on to this next one then. So on my next one here, this one here is example 3. This one here is example 3. Now, the problem with this one here is we've got to notice that they don't give us our diagonal length here. They don't give us this diagonal length. So this is what makes this a little bit trickier again, because we've got to use a method with triangles to find out what that diagonal length is. Now, we know, let's just draw a little, in fact, let's write a little sentence here. Let's just write a little sentence, actually. Let's just write a little sentence. Sometimes they will not give us the diagonal length of the cone. If this happens, we must use Pythagoras to find out what the diagonal length is. So sometimes they will not give us that diagonal length. And if this happens, then we've got to use Pythagoras to find that length. So just while we're doing this one, the first thing I'm going to do, always, I'm going to write out what the radius and the diameter is. Well, my diameter in this one is equal to 6 centimetres. My radius is equal to 3 centimetres. So, I know that from this part here to this part here is 3 centimetres. I know that this vertical height here is 15 centimetres. This gives me a right angle triangle like so. This is the right angle triangle where the height is 15 and the base here is equal to 3. So here we've got this right angle triangle. So we've then got to use Pythagoras to work this out. So let's label it first. So here we've got, obviously we know that opposite the right angle is C. We know that the one on the left is called A and the one on the bottom is called B. So we then write down the Pythagoras' theorem, which is a squared plus b squared is equal to c squared. So then I'm going to sub in what I know. So it's going to be 15 squared plus 3 squared is equal to c squared. So let's work out what they are. So 15 squared plus 3 squared is equal to 234 is equal to c squared. And then to find out c, I need to square root both sides, which is going to be the square root and square root. So the square root of 234, which is, so c is equal to one decimal place, 15.3 centimetres. So that's our starting point there. We haven't actually got into this question now. All we've worked out there is the fact that we now know here, that diagonal length there now is 15.3 centimeters. That's what we've worked out. Okay, we know that diagonal length there on that left-hand side is equal to 15.3. So this one here, we now know. And once we know that, now we can work out this surface area. So we've got to do the curved surface. I'm going to call that CS is equal to pi RL, which in this case is pi times by my radius, which is 3, times by L, which is 15.3. So let's have a go at that one there now. So shift pi times by 3 times by 15.3 is equal to 144.2 centimeters squared. Now that's for the curved part, the top curved part. For the circle on the bottom, it's going to be equal to pi r squared, which is equal to pi times by 3 squared. So shift pi times by 3 squared, which is equal to 28.3 centimeters squared for the bottom. And then I need to add both of these together. So 144.2 plus 28.3 is equal to a total surface area of 172.5 centimeters squared. That should be brilliant. So there's a lot going on there now. You've got to know the surface area, the curved surface area formula. You've also got to know to use Pythagoras to work out that diagonal. Okay, once you've got that, I think it becomes pretty easy if you know what you're doing with it, the other ones. But you've got to know how to do both of those things. So once you've got that down, have a little go at that one on the right-hand side. Have a little go at that one on the right. Take note of this one on the right. They've actually given you the radius this time, haven't they? So they've given you the radius this time. Okay, I can see that some of you are starting to get the answer to this, so I'm just going to start going through it because it is a tricky one. It does take a little bit of a while. So the first thing I'll write down is what the radius and diameter is. So my radius in this is equal to 22 centimetres, and my diameter in this is going to be double that, which is 44. Now, we don't actually need that in this one, but we're going to write it anyway. We draw out our triangle here. So here's our right angle triangle here, like so. We know that the base is 22. We know that the height is 32 centimeters. So it's going to be this triangle here, where the base is 22 centimeters and the vertical height is 32 centimeters. So we know that the opposite, the right angle, is C, and this is A and B. So it's A squared plus B squared is equal to C squared. So in which case it's going to be 22 squared plus 32 squared is equal to C squared. Let's just work out what that is. So 22 squared plus 32 squared is equal to 1,508. So I'm just going to do the square root of that answer. So that square root of my answer, it's going to do it all in one, which in this case C is equal to 38.8 centimeters there. Okay, so this length here we can now put in is this length here, which is 38.8 there, like so. Brilliant. So now we've got that part, we can find out what the surface area is by doing the curved surface, which is pi r L. So this is equal to pi times by 22 times by L, which is the 38.8. So let's just work out what that is. Shift pi times by 22 times by 38.3 is equal to 2,647.1 centimeters squared, like so. Don't forget we need that circle on the bottom. The circle on the bottom is equal to pi r squared, which is equal to pi times by the 22 squared. So let's just work that out. So shift pi times by 22 all squared is equal to 1,520.3 centimeters squared. So don't forget to find the total surface area. We're going to need to add these two together. So it's going to be 26.47.1 plus 1,520.5, which is equal to total surface area, which is 4,167.6 centimeters squared. What mistake have I made there? Oh, I have made a little silly mistake, haven't I? Let me just correct that. So I just copied it over wrong. It's this part here, isn't it? That should be 38.8. So just correct that. So it's going to be shift pi, just clear all that, shift pi times by 22 times by 38.8, which is equal to 2,000, it's not going to make that much of a difference, but it's definitely important, 2,681.7 centimeters squared there. So then that's right now. So let's just add those together. 2,681.7 plus 1,520.5 is equal to 4,202.2. So 4,202.2 centimeters squared. So I made a little silly mistake there. I can see that Some others have made little mistakes there in terms of what they're doing, in terms of that last little part. But if you round early, you'll lose some of your accuracy. So try not to do that. I probably should have kept these a little bit more, well, because they're longer decimal places. I should have done them more accurately. But yeah, we're there with that. Just be careful. Try not to make those mistakes that I've made, okay? So that was that one there. So, work out the total surface area of this hemisphere. Now, we have looked at this one before. So we know that we've got this part here, which is we draw an oval if we're going to draw it, and then we're going to do a line around an arch on the bottom here, like so. So, the problem with this is when we work out the surface area of a full sphere, which is 4 pi r squared, it gives us the full surface area of the sphere, doesn't it? Now, when we cut it in half, we're only working out the curved surface area, also the curved area on the bottom. So again, similar to the cone, we need to add that circle on top, the surface area of the circle. So this one here isn't too difficult. I'm just going to quickly go through it. If you know what you're doing, it is a tricky question. It's kind of one of those higher grade questions. However, yeah, I think we should be fine with it because we've done so much practice on this. So we know that the surface area of a sphere is equal to 4 pi r squared. Let's just write down what the radius and diameter is first. So my radius is equal to 8 centimeters. My diameter is equal to 16 centimeters there, like so. So the sphere is going to be 4 pi times by 16 squared. So 4 shift pi times by 16 all squared. I'll leave in terms of pi for now, which is equal to 1024 pi centimeters squared. So that's the formula for, that's the area of the sphere. Now, remember, this is a hemisphere, so when I divide this by 2, all I'm working out is the bottom curved part here. So let's do that first of all. So let's do the curved bottom, which is going to be this divided by 2, which is equal to 512 pi centimeters squared. Now I'm going to keep that in terms of pi, highlight it so I know which one it is. So I've got that curved bottom part. Now I need the circle on the top. So let's just label this one here. So the circle on the top, we know the formula for a circle is pi r squared, which is going to be equal to pi times by 8 squared in this case, which is 64 pi. Silly Billy, I'm making more mistakes again, aren't I? So that there should be 8 squared, shouldn't it? So shift pi times by 8 squared is equal to let's just work it out again. So 4 shift pi times by 8 all squared is equal to 256 pi centimeters squared. So the curved bottom is going to be half of that divided by 2, which is equal to 128 pi centimeters squared. I'll highlight that because we know it's the bottom. So we then need the circle, which is it is 8 squared, so it's 64 pi. We're going to need to add both of these together. So that's going to be 128 pi plus the 64 pi, which is equal to, so 128 pi, 128 shift pi plus 64 shift pi is equal to 192 pi in terms of pi centimeters squared. To three significant figures, it's going to be equal to, so the third significant figure is that 3 along there, so it's going to be 603 centimeters squared to three significant figures. Brilliant. 3 marks, that. Let's just check it. 603, super. Give you a second to get that down. Super. So, we've got this question here, which is kind of stepping up again. We've got a few more questions to go now. We've got 2 or 3, and then we've got the worksheet here, so should be able to get these done. So this one here is about working backwards, isn't it? So it's asking us to find the volume of the cone. Now the problem here is there's a lot that we don't know. Okay, this one here is 5 marks. This one here is tricky, really tricky. Okay, the only thing they're telling us is the slanted length and that the surface area of the cone. So the curved, that's lucky because that would have been really tricky. The curved surface area of the cone is equal to 100 centimeters squared. So let's write down the formulas that I need to know for this. Now, the formula for the curved length, so the curved area is equal to pi RL, we know that. We know that the volume of a cone, we have done this, is equal to the area of the base times by that perpendicular height divided by 3. So it's the base area. In fact, I'm going to just write it out because we know that the base is a circle. So it's going to be pi r squared, which is that circle, times by the vertical height, which is h, all divided by 3. All divided by 3 there, like so, because it's a cone. So the first thing that I need to do here is to work out what that radius is, because I can work this out using this formula here, using the length and the surface area. So I've got to work backwards with this. So let's do that first. So I'm going to sub, remember, when we're working backwards, you've got to do the same things. You sub in what you know, you simplify, and then you solve working backwards. So we've wrote down the formula already. Let's sub in everything we know, which is going to be equal to 100 is equal to pi times by r times by L, which is 9. So I don't know r. So this is going to be equal to 109 pi r. So to find out r, I need to divide both sides by that 9 pi. So divide by 9 pi, divide by 9 pi. Let's just have a look at that now. So 100 divided by 9 shift pi. So r is equal to 3.5 centimeters squared. R is equal to 3.5 centimeters squared. So that's a good start. Now, the next thing that I don't know here. So now let's draw this in. This here is equal to 3.5. Now, the next thing I need to know to find out the volume is this perpendicular height here. But I don't know what that is, but I can, same as before, use Pythagoras to work this out. So I'm going to use Pythagoras here, like so. Okay. So I know that this is 9 centimeters. I know this bottom is 3.5. And this now is the one that I need to know. Now remember, this one opposite your right angle is C, the bottom is A, and this one is B. So I'm actually finding out one of the shorter sides from Pythagoras. So let's write down what Pythagoras formula is. So A squared plus B squared is equal to C squared. I'll sub in everything I know, which is going to be the 3.5 squared plus B squared is equal to 9 squared. Now the problem that I've got here is that because I'm finding the shorter side, I need to take away that 3.5 squared from both sides. So take away 3.5 squared, take away 3.5 squared. So I end up with B squared is equal to 9 squared minus 3.5 squared. Let's just work that out. So 9 squared minus 3.5 all squared. So B squared is equal to 68.75 centimetres. It's not centimetres, sorry. Not yet. Because I've got to then work out what B is by square rooting both sides. So let's square root and square root. So B is equal to 68.75. The square root of 68.75, which is equal to 8.29 centimetres here. Now, remember, I'm just going to take a step back for a second here, because this isn't easy. We've just worked out the height. So we knew what the surface area is. Don't worry too much about that. I think I've made a slightly different round should work. So I've worked out the radius using the curved area formula. I've then used Pythagoras to work out the height, and now and only now can I find out the volume, which is going to be equal to pi times by my radius, which is 3.5 squared, times by the vertical height, which is, I'm just going to check. So, yeah, times by the vertical height, which is 8.29 stays the same. All divided by 3. So pi r squared times by the height divided by 3. So let's just work out what that is. So shift pi times by 3.5 all squared times by 8.29. I should have done all that divided by 3. There you go. Divided by 3. So pi times by 3.5 squared times by 8.29, all divided by 3. So we're linking everything we've done so far, aren't we? Is equal to 106 centimetres cubed because it's volume. There we go. Why can't I do that? Super. Let's just check that. Ooh, where have I gone wrong there? I think that calculator error has made a mistake going forward, hasn't it? So we have got all the answers right though. 3.5, 8.27. So I think this is my little mistake here. I think I just typed this one in the calculator wrong. So 2.7. This one here is 8.27. So if I type that in, I should get 108 centimeters cubed. Brilliant. All right. So we'll finish up that one up there.